Hello everyone, welcome to my online course Microservices with Spring Boot and Spring Cloud. I'm going to show you how to build microservices architecture efficiently with currently the most popular Java framework Spring Boot, and also how to implement microservices design patterns like service discovery, distributed configuration, or client-side load balancing with several projects from Spring Cloud. In the first part of my course, Introduction to Spring Boot, I focus on demonstrating features especially usable for building microservices. I'm assuming you already have an experience in implementing applications with Spring Boot, so I would not talk about the basics. The biggest difference between monolithic application built on top of Spring Boot and microservices is of course at scale. If you are running plenty of applications, the most difficult challenge for you is an efficient monitoring and management. The features, which are just optional for monoliths, became a key for microservices. A key name here is standardization. We need to define some best practices that needs to be respected by the application authors. Let's perform a short overview of those best practices for microservices. The good news here is that it's relatively easy to enable all these features with Spring Boot. Almost all of them may be enabled by configuration. Some of them requires external libraries, but they can be easily integrated with Spring Boot. Metrics give you a big picture of your application current status. You may easily verify number of exceptions or detect resources usage. An approach to metrics implementation depends on the tool used for collecting metrics. If you are using pull-based tool like Prometheus, you just need to expose they with the endpoint. If you are using a push-based system like InfluxDB, your application needs to send metrics there. Spring Boot uses Micrometer project for generating metrics and comes with a predefined set of metrics. On the other hand, logs helps you to go deep inside the details. The proper implementation of logging is a story for a separated presentation, but for microservices you should focus on using the right tool for collecting and searching logs. They should be stored in a single, centralized place. Keeping them in files on file system does not have a sense for microservices, especially if you are running them inside containers. Another important aspect of microservices development is to expose some information about application. It includes such information like version, git commit data, or detailed REST API documentation. In that case, you can also use dedicated tools for that. API documentation may be automatically generated by Swagger, while version or git commit ID with Spring Boot Actuator. Since microservices are independent applications, they should not share the same resources. That's a reason of Docker popularity for microservices-based environment. You can easily separate such resources like CPU or memory between containers. You may also set limits. I show you how to build and push image with your application to registry using Zip plugin provided by Google. We will also run container with our application locally and integrate it with tools for collect logs. And the last topic is testing. I would not show advanced tool for it because it would be discussed in the next dedicated part of this tutorial. What I'm going to show you is just a simple usage of Spring Boot test to verify if our REST API works properly. I'm going to show you the implementation process of sample Spring Boot application written in Kotlin. It follows the currently discussed best practices. You probably heard about Start Spring IO site. You can easily generate there a template for your Spring Boot application, build tool, language, and a version of Spring Boot. We are creating Maven project written using Kotlin. The selected version of Spring Boot is a current stable version, which is 2.6 release. After that, we are setting artifact ID, group ID, and base package name. The selected version of JDK is 11. Finally, we may include some libraries into our current project. We are choosing starters with Spring Web for REST endpoint features and Spring Boot Actuator for adding management and monitoring endpoints. We may generate and download source code by clicking Generate button and then import it to our IDE. Let's switch to IntelliJ IDE. Now let's switch to IntelliJ. As you see, I have already imported the project. Let's take a look on the Maven POM XML. There is dependency Spring Boot parent in the version 2.6 release. We just need to change version of Kotlin nested lib by removing JDK 8, since we have already set JDK 11 as a default SDK. The source code generated by a Spring Start.io site contains also Spring Boot main class. We need to add some sample code. Since we have a simple application that only exposes some REST endpoints, we need to create domain model class, an in-memory repository implementation, and REST controller class implementation. Sample application will be just exposed CRUD operations for person objects. We are beginning from person model class implementation. It uses Kotlin data class feature that provides built-in implementation of such methods like toString, hashcode, and equals. It has such field as ID, first name, last name, and age. Only age is updatable. Now we are creating an in-memory repository of person objects. The class is annotated with repository annotation. It initializes a Kotlin mutable list inside the constructor. It contains methods for adding, removing, updating, and finding objects in the list. It's using Kotlin Collections API. As you see, we are starting from findById method. It returns a single person object and uses find method for searching an object. We are also creating findAll method that returns all the objects inside the list. The next three methods are used for deleting object by ID, adding new object into the list, and finally updating an object in the list. It is also find using ID. We are using index of first Kotlin collection method to locate the object. And finally, we are setting selected object in the list. Since we have already finished an implementation of repository class, we may proceed to the controller class. It is annotated with REST controller annotation. We are also annotating it with request mapping to provide a default path for our controller. We are injecting repository bin to the controller in the constructor. The method names inside controller corresponds to the names of methods inside repository class. We are using Spring Web annotations like getMapping, postMapping, deleteMapping, and putMapping to expose methods as HTTP endpoints. FindById method takes an ID parameter from path, therefore it should be annotated with path variable. FindAll method returns the whole list of objects. The delete method also takes a single ID parameter from the path and removes the object from in-memory repository. The last two methods for updating and adding objects to the list takes the whole person object as parameters. Since the input object is sent in JSON format, we need to annotate it with request body. The implementation of controller class is finished. Since we are finished implementation of controller class, we can run our application. We can easily do it using IntelliJ mechanism. We need to wait for a moment until our application starts. It might take some time. As you see, it is listening on default port 8080 and it is exposing two Spring Boot actuator endpoints, half and info. We can easily test REST API exposed by our application by using curl in IntelliJ. We are calling endpoint responsible for returning all the objects inside the list. Since there is no test data, it's returned an empty list, so we need to add some test data using post method. We are adding two objects into the list. As you see, we are sending it in JSON format. After adding it, we may call our method for returning a list of objects once again and see that the objects has been added into the list. Let's move back to the Maven POM XML. We will add a configuration to Spring Boot Maven plugin responsible for generating build info properties file. To do that, we just need to insert the goal build info to executions. Spring Boot actuator is able to automatically detect build info file on the class path. To generate it, we should build our application with Maven. We are executing Maven clean install command. We are also adding command Spring Boot run, responsible for running our application just after build. Let's wait for a moment until the build is finished. See that currently it is running tests. Okay, it is starting our application after build. It's also available under port 8080. You can check out if the application answers on the request. We are just calling endpoint for displaying all objects inside the list. And now we can test our info endpoint. Before that, let's take a look on all the endpoints displayed by Spring Boot Actuator. You see that it is displaying halt and info, and now we can check info endpoint. You see that it's printing the version of application and the build time, together with name of artifact and group ID. Now we may back to the code and check out how the plic was generated by Spring Boot Maven plugin. It's available under target directory inside classes metainf. Here it is. Now we are proceeding to the next step of our tutorial. I show you how to enable automatic generation of Swagger OpenAPI documentation for our REST API. We'll use library Spring Doc for that. It supports a third version of OpenAPI specification. We need to include two dependencies to our POM XML. First of them is dedicated for supporting Spring MVC endpoints, while the second embeds Swagger UI into the application. After changes, you should restart the application. The generated Swagger manifest is available under path v3 API docs. We may also display it in a more elegant way by using Swagger UI, available under Swagger UI HTML. It allows us to test each REST endpoint the same as we are doing it using a curl command. You can add a single person by calling a post method and then verify it if it's existing inside a repository by calling get method persons. As you see, it is returning a valid data. Now we are moving to the Spring Boot application properties file, and we are changing its format from properties into YAML. To show you, set a dynamic port. Until now we were running our application on default 8080 port. You can override this number using Spring configuration properties. But if you are planning to run multiple applications on the single machine, you may take an advantage of dynamic port allocation feature. You just need to set 0 as a server port property value. After such change, Spring automatically allocates unused ports from a higher port number range. Let's take a look on the logs. Our application is starting. As you see, Spring has dynamically allocated a port number, and now it is 59012. We can check out if our application listening on that port. Okay, we are still in the road to success, so let's keep pushing. It's time for enabling metrics. I show you how to use Spring Boot Actuator to export endpoint with metrics for Prometheus. Prometheus is a pool-based system, so it's trying to collect data by calling application endpoint. The same as before, it won't cost us a lot of work. First, we need to include a Micrometer library responsible for integration with Prometheus. As I have mentioned before, Spring Boot Actuator by default exposes only two endpoints, info and health. We can enable additional endpoints through our configuration properties, enable a single endpoint, or just enable all additional endpoints. We are also enabling more detailed information for health endpoint. Let's restart the application. And after that, test the changes. Okay, it is still available on dynamically generated port, so we can take a look on all the endpoints returned by a Spring Boot Actuator. As you see, there are pretty many endpoints. There is also Prometheus endpoint available. Let's take a look on the health check endpoint. Additionally, checks disk space. And let's take a look on the Prometheus endpoint. The data is returned in Prometheus format. We may take a look on predefined metrics like JVM memory, JVM treats, a number of HTTP requests, and some other things. Our next topic is logging. We'll use three tools being a part of Elastic Stack. Logstash, Elasticsearch, and Kibana. The application needs to send logs to Logstash, and then Logstash is forwarding them to Elasticsearch, which is responsible for storing them. To enable log sending, we first need to add dependency Logstash logback encoder to POM XML. In the second step, we have to define logback appender inside logback Spring XML configuration file. We are using appender provided by Logstash logback encoder library. We are creating such file since it has been not created already. We are defining appender, and we need also to set destination address, and we can also define some custom fields like application name. We are also enabling ANSI output for the application. Our logs would be pretty print on the console. And now we are restarting application after changes. As you see, Logstash is currently not listening on the destination address because we have not already run it. But our application is starting successfully, so we can proceed to the next part of our. I show you how to run Elasticstack on Docker and send logs, application logs there. We will build Docker image with our application. There are several Maven plugins designed for building Docker image with application. Personally, I prefer Jeep plugin from Google. If we don't have any advanced configuration, we should just set a target name of generated Docker image. It's a POM intro to Spring Boot. The name POM is corresponding to my account name on Docker.io. After running a plugin to POM XML, we have to run Maven git build command. So we are going to the terminal. We are executing also Maven compile, and after that we are running git build command. It is running in Dockerless mode, what means that we don't have to start Docker daemon to be able to perform a build. It's very comfortable, and it's one of the big advantage of Jeep Maven plugin. We need to wait a moment before the image is built. After building the image, Jeep plugin now automatically tries to push it to Docker registry. So before running it, you should at least log into your Docker Hub account once. As you see, it takes a long time. With the first running of Jeep command, it needs to push the whole image to the registry, as you see. Additionally, I slowed down my network to show you the differences between the first and second run. As you see, it spans 17 minutes to build and push this image, so it takes a long time. And now we'll change another thing, because I've already left the configuration that enables dynamic port generation. It's useful for local development and for running multiple applications locally, but it's unusable for building Docker image because we need to set a static port which is exposed outside Docker container. So we are removing this and creating application properties with dynamic port only for dev profile. After changing these properties, our application is starting on listening on port 8080, so we may perform a build one more time. You'll see the difference in time of pushing Docker image to the registry. As you see, it is just pushing a delta, so the push and build takes 25 seconds. As you see, you are seeing my Docker Hub account, and the image intro to Spring Boot has been already pushed to this registry. Now we may move back to running Elastic Stack in order to demonstrate integration between our Spring Boot application and Logstash. We're switching to Docker. Now we are creating a new Docker user to enable communication via hostname between containers. Therefore, we'll also set a name of each container which hostname is equal to the container name. We are starting from running container with Elasticsearch. As you see, we are running it in development mode. As a single node, we are exposing 2 ports outside the containers. The same with Logstash. We are running the newest version of Logstash. It is exposed under port 5000. Both these containers are running inside already created network micro. We are also running Kibana, which is integrated with Elasticsearch only for searching and displaying the logs. After running Elasticsearch on Docker, we may proceed to running container with our application. We are exposing it on port 8080. The name of our container is intro, and we are using an already pushed image to my Docker Hub repository. You can take a look on the logs. Our application is starting, as you see. These are logs from application container. It's available on port 8080, and you see it has been successfully started. Now let's switch to Kibana. Kibana is available under virtual address and port 5601. We are running it for the first time after creating containers, so we need to create index pattern. Kibana uses index patterns to retrieve data from Elasticsearch indices. As you see, it is already printing an existing Elasticsearch index for our application. We are defining a main column for our index. It's timestamp. We need to wait for a moment until an index is created, downloaded to Kibana, and we see that there is a list of fields. We can switch to logs view. As you see, our application was starting and it sent logs to Kibana, to Elasticsearch. So it's all. Okay, and the last topic is testing. Start Spring IO site has generated very simple tests without an interesting test for us, so we will change it a little. We are defining a web environment with a static defined port 8080, and we are injecting test-rest template for calling our endpoints. Our first test method is test add. Is testing a post method for adding new object into the repository. We are creating person object. We need also create HTTP entity because we are using an exchange method provided by test-rest template. We need to define URL. Test-rest template is automatically integrates with application started during the test, so we don't have to provide a more detailed address. We just need to insert a path of endpoint. Endpoint does not return any objects, so we are defining a voice response, and we are asserting that response HTTP code is equals to 200. After defining a test, you can just run it using IntelliJ tool. As you see, it is already starting our application during the test. It's starting on port 8080. It's available just during the test, and the test has been succeeded. Okay, now we can add some additional tests, but the first step is set an order of the test. We are using test method order annotation for it and order annotation for each test method. Okay, we are adding another free test method for each HTTP endpoint exposed by the application. Now we are creating a test method for find by ID method and get endpoint. We are expecting that it returns a single person class, since the test that adds any entity into the repository is running before our current find by ID test. We are expecting that object with ID1 is existing into the repository. So we are asserting it is not null and the returns objects has ID equal to 1. We are also adding a test method for deleting and test method for updating an objects. These are really simple methods that just are testing that an object is existing in the repository or that a method has been finished successfully. Test put method is running after find by ID, but before delete. So we change an order for delete method, and now we are able to run all the tests. The application is starting, and you see that after that Spring Boot is running all the tests are succeeded. So it's all. Okay, we proceed to the last phase. In the first part of our tutorial, we will push our source code to GitHub. It will be available under Curse Spring Microservices repository. I will also add there all other examples for the next part of tutorial, so you can easily access them in the single repository. Now we are choosing the code to be pushed into the repository, and we are pushing just intro to Spring Boot application. The code is now available on my GitHub account, so you can easily take a look on it and check it out on your local machine. Since we have added our project to Git, we can also add a plugin for exposing that allows us to expose Git data information in the info endpoint. We need to add Git commit ID plugin. Now the plugin is running during the Maven build. It is generating a Git properties file. It's available in ClassPath. Spring Boot Actuator is able to locate such file on the class path and automatically expose all the properties from this file to info endpoint. We are performing Maven clean install and Spring Boot run go. As you see, the Git commit ID plugin has been executed and it generates a Git properties file. In the logs, and after that the application is starting. It's available on port 8080. We will verify that info endpoint returns information about Git commit ID and Git commit date. And it's all in this part of tutorial. Thank you, and see you in the next parts of my tutorial.